Hello everybody and welcome. Today we're going to make this Houdini Digital Asset. That's a table, and you can do a table inside Unity. And you can also use Unreal if you want. It works pretty much the same way. So here we have it, a table, and you can change the width of it, the length, and you can do top thickness like this, height of course, and offset. This is if you want to offset the frame under like this. And also the legs are square, but you can change them to a round one like this. So yeah, maybe you want a butcher table. You want a little bit more. A butcher needs steady things, so I would say this is a butcher table. Yeah. So let's do this from scratch. So I'm going to delete this one. And the first thing we're going to do it in Houdini, almost everything. First off, we're going to make a geometry node in here. This is going to be the table. And we will make a controller from a Wrangler. So this is going to be a controller with all the settings we're going to have. And it's important that this runover is detailed because it's only once and it will always run. If we have primitives, points, vertices, numbers, then we must have something going in here, and this determines how many times the loop goes. But if we do detail, it's only once and always once. So then, for instance, we could have a, here we do the top part, so we have a float width, and that's going to be width, of course. We're going to have a length, and that's going to be the length. And we might as well do the top thickness when we're at it. Top thick. Whoops. Thickness. And if we press this button here, we have them exposed like this. So I'm going to make this one green. You can press here or use the C key and color it. And we will make a grid. And it's so easy. So this will determine our table size. The row is going to be 2. The column is going to be 2. And also the width and length. If we do right click, copy parameter, then we just do paste relative reference in the X. And the length, we do the same thing, copy, paste here, and then we have it. So this is like the base of the table. So now we can change the size like this. So from here, we're going to build different parts. First thing we're going to do is do the top, and that's what we're going to do with the poly extrude like this. So same thing again. If we do here, top thickness, right click, copy parameter, and in this poly extrude we do in the distance, because we're going to make the distance here, right? So if we do right click, paste relative reference, and now we have the thickness. And if you see down here, there's no bottom, so we just need to put output back. So we have the back. And to finish this, we also want to have an unwrap, because this is going to be procedurally UV mapped. And if I do space 5, we see it's UV mapped. And if we change these parameters, you see like this. But there's a catch here. So look at this board, and if I do, you see the size of the grid is kind of changing. So what we want to do here is not do uniform, but none. So now if we do some, you see the square is the same size, and that's what we want. We want it to always be real world UV mapped, because then we can always use real world material, world scaled material. So we never need to do a separate material for each asset. And we're going to make the thickness to 10 centimeters, and I want to do a bevel. Poly bevel like this, and just a tiny amount on the edges. It makes a nice detail effect. Yeah. So this I'm very happy with. So this is the top part. We're going to do top, finished, great. Next thing we're going to make is the frame. So the frame is, let's see if we do the classic table again. That's this frame under here that goes around like this. So we're going to make sure we do that. I think you understand what I mean. Yeah, you see this frame around here. So we have the shape. So we just need to, again, do a poly extrude. And this time we are going to do not distance like this, but we're going to do the inset part, because we want to, if we don't output the sides, now you see that we kind of just minimize it. And also we just want the dots on this thing. So if we add an add node and just delete geometry but keep the points, now we see we have points. So these points going to represent the center where the leg's going to be. And so this inset needs an inset value. We're going to change that later, or actually we could just make it right away. So we're going to have an inset part, and we might as well do the leg part too. So the leg will have height. And also we need the leg thickness. Leg spells like that. All right. So the way inset works here, we can look at it again. So the distance you see here, 18, it's 18 centimeters from the edge inwards. From the edge inwards like this. So if we know the thickness of the leg, then we know we can just extrude it inwards, the half size of the leg thickness, then we get the center of the leg. So what we need to do here, we need to do an F and at inset val like this. And this is going to be equal to leg thickness, and it's going to be 0.5. So what we've done here, we actually, if we see here, we have dots, vertices, prims, and detail. So we actually made an inset value on detail up here. And now we want to get that, because we can't right click and copy this one. We can't do it like we do here, right? So we need to, in the inset, we want to fetch a detail information that you see here, the inset val. So then we just do detail, detail, and then we got three values, string, float. So that's the node, and this is going to be a controller, and the attribute name is going to be the inset val, and the attribute index, because there is only one index in a float, it's going to be 0. But if it would be a vector, we could have 3 index. A vector 3 could have 3 index. So then if we would like, let's say x, y, z, and then we think we want the z part, then we do it number 2 here. So in our case, we do slash dot dot, no, dot dot slash. Then we leave this node and get out to this big gray area. Now, if we see the controller, we can choose it here, or just controller. So now we went up to this node, and then we want to fetch the value in set val, and we want to fetch the first index. And we need to press this button here to expose these parameters like this and change them from 0 to something. Now you see, so let's say the legs are 20 centimeters and the extrusion is only 10 centimeters. So this is great. And actually, this part we're not going to have here yet. I was thinking wrong about that one. So what we have here, we have a line. So this line, we can extrude along it. So we're going to use a sweep. And this sweep node is having a warning because it expects something to be in the second input. But we can change that and do surface shape second input and do square. And now we have the frame that we're looking for. No columns, so we want it just like this. And the width, it's going to be leg thickness. So leg thickness, copy parameter like this, and paste like that. Now it's super procedural like this. So if we now take these two together, they are connected. And the last thing, we just need to move down the frame and unwrap it as well. So first we're gonna, because you can see it's kind of intersect here, looks bad. So we need to move it down a bit with a transform like this. And it's going to be -1 times leg thickness, paste relative reference. And well, if we do that first, you see it's the half amount that we're looking for. If we want it only to be moved down the half size of the leg thickness. So we just do multiplied with 0.5. So now we have that part. And we leave it like this, something. And UV map with the... So in the sweep, we have this really nice UVs and attributes. It's a lot of things we can do here. So if we check the UV maps, there is nothing. And actually we can do another one here. Scene. We do this one. So here we see the model, and this is the UV map. It's empty. So compute UVs, we have it. But it's actually not, you can see if we reference the last part, you can see that it's not the same scale. And the reason is that we in here we normalize computed UVs, and we also snap it. So you can see it snaps to the grid. So if we remove snap to grid, you see it's fixing that part. And we also don't want to normalize the computed UVs. And then we can remove this snap UV. So what happens now, that now it's the correct way of UV map it in real world scales. You see will always be the same size. Super nice. Cool. So now we're going to have this one again. Just a copy of this one because we need to inset things that we did. And now we're going to have an add node like this. Because this part is going to be the legs. And we are going to use a line like this and put it into a copy to points. This one. So on each point, we're going to add this line like this. So you see, well, we can do like this. So this is the legs, but they are pointing upwards. We're going to change it to, instead, direction is positive I, but we're going to do -1. Now you see them are pointing down. And in the controller, we have the height. So we can do the table height. We just do copy. And in here, we do length. We do paste. Now we get the length of these ones. But they are, let's see, so we want the table height to be 1 meter-ish. And we're going to add, we're going to have the shapes here. And it's going to be a circle. This is going to be a circle. That's going to be the shape of these lines. So if we do a sweep and put the lines like this, and now this one wants in here the shape what to extrude, and we just plug this one in, and now we see we have the legs. Of course they are too big, and we also need to reverse this shape, and we also want the leg thickness, copy it, and the radius we do paste relative reference, and radius is needs to be the half of the thickness. And we do the same on the next one. Because if we don't do 0.5, we are putting in the diameter measurement into the radius, and that's wrong. Okay, so this is wrong. We're going to do right-click, paste relative reference. And if we just plug this one in here, and I'm just going to reorganize the lines like this, and we're starting to see the shape of the table. There are some stuff to fix, but this is really good. So I'm going to take a file, save as, and make sure I save it in this one, in here. So now I have it saved, and I'm gonna pause the tutorial here and continue in the next one. Thank you so much for watching.